So thank you everyone for attending the Pioneering Green Energy in the NHS event, a very, very potent and important topic at the moment. So appreciate everyone's support. We have a really, really great lineup today. I'm not going to take up too much time this morning on who the sustainability partnerships are, because I know that we have a lot of re-attending visitors to our events, so I won't talk too much about who we are. We've actually had a bit of a change to the order of our lineup this morning. We're actually going to kick off with Jordan Appleson, who's the CEO at Hark. We're then going to move on to Azad Kamiab, who is the CEO and founder at Pearlstone, and then we're going to finish off with a presentation from Rupert Lane, who's the Global Enterprise Solutions Consultant at Infogrid. As usual, everyone please use that chat function as much as possible. Have your own conversations there. Feel free to use that and leave notes, comments, points, and then there's also the Q&A function. What we're going to do is we'll go through all the presentations first, and then we'll have a Q&A session at the end. So any questions, please put that in the Q&A and I'll field that to our experts when we get into the Q&A session. So without further ado, Jordan, I'm going to pass over to you. If you want to share your screen, say hello, present your deck and give an intro to who you are.
Yeah, absolutely. Thanks, Georgia. I'll just echo what Georgia said around thanks to everyone for giving up a little bit of your time today to come here as talk about green energy. My name is Jordan Appleson. I'm the CEO of Hark. As a bit of background, I've spent the last I suppose, almost 10 years connecting all sorts of assets to the cloud for real-time monitoring. So that's things like energy meters, building management systems, wind farms, energy storage. And what Hark are as a business is we're an industrial IoT and energy analytics company. I'm not actually going to be talking much about technology today. I've got a satirical comedy for you. But basically, our mission at Hark fundamentally is to help improve the way the world performs, and that's helping companies improve efficiency, maximize output, and reduce waste. So that's things like optimizing buildings, optimizing assets, monitoring energy, all sorts of stuff. We typically do that with supermarkets, factories, commercial buildings, and also the NHS, the wider smart buildings program for the NHS as well. So that's me in a nutshell. But actually, I'm going to be talking today about what is green energy, like, seriously. So I was asked to do this talk, and I thought it would be a really good example, like, to give what kind of green energy is. So I kind of started to look at all the different questions people had around green energy, right? And what I've come to find out is green energy is quite a vague term. Right, it's quite a vague concept, and other questions surrounding around what green energy actually is come up, like, is green energy the same as renewable energy, or is green energy carbon neutral? Is green energy cheaper than non-green energy? Is green energy and low carbon energy the same thing? Does using green energy mean I'm contributing to the reduction of carbon emissions? Is green energy more efficient? And the answer to those questions is basically, it depends who you ask and when you ask it. And I'm not joking either. It's quite interesting. So when we think about green energy or energy in general, what are the kind of types of fuels in the mix for power and heat, right? So electricity or heating systems. You've got, coal, solar, hydropower. These are kind of relatively straightforward. Natural gas, which we hear a lot of due to the current climate, I'm sure. Biomass is quite an interesting one. So that's we're going to go into that a little bit more in more detail. And then you've got, things like offshore and onshore wind and your nuclear. So which ones of these kind of fuel mix are considered green? Obviously, coal is definitely considered green, right? I'm joking. I'm joking. But just on the point of coal, right? Just to give you an example of our move away from kind of coal over the last kind of 150 years or so, you can really see, when from the kind of the 1850s at the start of the industrial age, how much we actually produced and imported when it came to coal. So we were, in the height of, the 1900s, when we were really using coal for things like the age of steam, we were kind of mining and producing over 250 million tons annually of coal, and you can see how that's consistently reduced over the years. And in fact, we actually ended up by the latter half of the kind of 20th century importing more coal than we produced, which is kind of funny. It's kind of the North Sea gas fields all over again when it comes to our economy. But anyway, I'm not here to debate that today. So going back to the types of fuel, they're all very different. Some of them are classed as green, some are classed as renewable. Let's have a look at who defines what as and when. So let's have a look at what the National Grid say, green energy definitions. So the National Grid say, here's an easy way to differentiate between clean energy, green energy, and renewable energy. So green energy is sources from nature. Well, that doesn't sound very green when you think about coal, right? Okay, fine. Let's see what British Gas say. So what makes energy green? So green energy can be a bit of a vague term. It's generally thought to describe energy that has been created using natural resources. Okay, fine. To be considered green, it can't produce polluting greenhouse gases. Okay, fine. What do America say about green energy? Well, the EPA, they classify green energy as something that provides the highest environmental benefit and includes power produced by solar, wind, geothermal, biogas, low impact hydroelectric, and certain eligible biomass sources. Okay, so let's put that into context. If you're the National Grid, this is what green energy is. Basically everything, because everything's from a natural resource, right? Like, I'm now being flippant, but it's true, right? If you're asking the American kind of the EPA, biomass is on there, but coal and natural gas aren't. I've popped nuclear in the bottom right as kind of blue because like I have my own opinions on whether it's like green or not. Like I think, you know, there's the waste side of it, but in general, it doesn't produce any you know, CO2 in terms of burning things like fossil fuels, etc., etc. Fine. If you ask British Gas, you know, basically coal, biomass, and natural gas aren't based on that definition, right? I'm not saying they're definitely saying nuclear is green. It's just that by their definition of it can't produce, you know, polluting, and it kind of comes from natural resources, and then nuclear technically is classified as that. So let's just have a quick chat about biomass. What do we mean by biomass seriously? So biomass is, again, a term that can describe a lot of different types of fuels, but generally it's things that are plant-based or, you know, basically excess wood chip, energy crops, even things like biogas and stuff can be classed as kind of biomass as well. So what we're saying is biomass, which in certain cases is considered green, is burning this stuff, which is wood and sawdust and stuff that we grow in forests. So how that's green when we're going to go cut, you know, some people say, well, when you're buying biomass, you're buying land that you know, it's renewable because you can grow plants and then you can keep burning them. But it isn't really that efficient because the energy density of some of this fuel is you have to burn a lot more of it, which actually produces CO2 to get the same amount of power out of it, right? So it's quite an interesting point of differentiation. So how do different fuel mixes contribute to emissions? Well, this is quite an interesting graph. So here's a graph of basically, it's from the World Nuclear Organization from May 2021, or that's when it was last updated. And it shows, obviously, you know, coal being the highest emitter from a life cycle emissions point of view. From a fuel as a fuel source, it produces kind of 820 grams of CO2 per kilowatt hour. Okay, then you've got something called biomass co-firing, which is quite an interesting term, which is where they take biomass and then they mix it with coal and they co-fire it. So if you're going down the green biomass route, that's 740 grams of CO2 per kilowatt hour produced. Then you've got your natural gas, which obviously, you know, much less than coal, fine. And then you've got your standard biomass, which does produce quite a considerable amount of CO2 compared to other fuel sources. And then you've got, you know, your solar up there with 48. So you've got your geothermal, which we didn't touch on. You've got your hydropower, which is very, very low. But then when you're looking at the lowest in terms of emissions, offshore and onshore wind and nuclear are actually, from a life cycle cost per kilowatt hour, the lowest, right? But, you know, biomass in certain cases considered green, right? Sorry, I'm not trying to like pounce all over biomass. That's not my point. But anyway, so now we kind of have an idea of, okay, well, what are the fuel sources? How much do they emit? Are they different to renewable? Well, it depends on who you ask. How is energy priced, right? I'm not going to go into the pricing of the markets, generally speaking, but I am going to talk kind of in general terms. So the energy market is supply and demand driven. So especially with respect to electricity, when you turn on your lights, the actual supply, so the generation on the network at any one time, it must always equal demand, so the load. And for instance, last night when I was updating my deck, I had a look at what our fuel mix was and what was coming from where. So it was kind of 6:45. And the balancing mechanism who basically selects on, they report all this information on every kind of 5-minute or 15-minute intervals. They'll give you the fuel mix and they'll give you the demand and generation. And we could see, okay, 38%, or 38.5% almost was wind, so that's green. 48.4% was gas, not so green. 13% was nuclear, it's base load. And then you got your pump storage, your hydroelectric, your biomass, and it was nighttime, so obviously the sun doesn't shine. There's no PV. For those of you who are asking, why do these numbers equal more than 100%? It's because we're actually being good neighbors and exporting energy out to kind of, at the time, to kind of Belgium, France, Ireland, and Norway. And that's because, remember, the energy market is a supply and demand driven. If we can price it at a certain point, people will buy it from us. So exporting is good, right? Well, it depends who you ask. But what's really interesting about this is the green side of things is wind and hydroelectric, great. But when you think about pricing volatility, which is all something that we've continuously heard about over the last kind of 12 months or so, especially given the current circumstances. Well, pricing volatility, in terms of the gas prices, electricity prices, they occur because of both market speculation of the supply, so what people think is going to happen in the future based on world events. And I'm not talking about events nationally, I'm talking about global events. It is a global market. And obviously supply side shortages in real terms, and this is something that happens when, for instance, there's a power station goes off, we don't have enough supply on the network, then there's creates an imbalance, and then people will pay more money to stop things like blackouts occurring, for instance. So it's a whole market. The interesting thing about that is the renewables and the renewable sources that are green, that make up our UK mix, they're intermittent generation assets. So what that basically means is that they're not as predictable as, say, something like nuclear or firing natural gas if you've got good stores of it. It's not easy to use as base load in the same way as what coal used to be. And that intermittency then obviously has an effect on pricing volatility. And there's research that shows that the more wind in a market, actually there is a positive correlation to pricing volatility. And I guess that kind of maybe seems obvious when you've got the wind might not blow and you're out of electricity, price goes up. So what I'm trying to say here is the more intermittent generation assets we rely on, the higher the potential for supply side shortages. In this case, wind, green, is it cheaper? This is something that we have to consider. So just to give you some costs, how much does it actually cost to kind of build and operate some of these types of assets? So this is the estimated levelized cost. So basically how much it costs to build and operate over a certain period of time. So you can see kind of the cheapest is kind of large scale solar, with the most expensive being nuclear to build and operate. What's quite interesting is that the price of offshore wind and onshore wind has come down over 50%. I mean, that's quite interesting. It is much cheaper to build wind than it ever has been. There's an interesting point around gas, that there's gas with carbon capture technology that seems to have levelized out with standard gas on a price per megawatt hour perspective. And then you've got your kind of really expensive nuclear, which has gone up because only governments really build nuclear, and they seem to go on and on and on when it comes to that. But the interesting point here is that the biomass piece is come out at £97 per megawatt hour. So, and again, some people class it as green. It's quite expensive in comparison. So, let me try and answer all these questions that I kind of threw up originally. Right? What is green energy? Well, is green energy the same as renewable energy? Well, again, this depends who you ask and when, but the answer really is no. No, it's not. Is green energy carbon neutral? Not on its own. No. No matter what type of source of fuel you use, the levelized cost is always some part of carbon emissions that go into the build or the operation of those assets. Is green energy cheaper than non-green energy? Yes, to build, if you're classing kind of solar and wind. To operate, I think the jury's still out because of the way that the market's priced. It's a global market. Is green energy and low carbon energy the same thing? No, and it depends on which different definitions. If you go by the EPA, or you go by the National Grid, or you go by British Gas's website, it depends on which definitions you use. Does green energy mean I'm contributing to the reduction of carbon emissions? Yeah, I think that's safe to say. Yeah, you know, if you're using more biomass that's not co-firing, by the way, or you're using more natural gas and coal, and obviously you're gonna be contributing to the reduction of carbon emissions. Is green energy more efficient? Honestly, I have no idea. And I don't think Google or the amount of research that's out there via Bayes can really say yes or no. I think, again, it depends. Like I said earlier, if you're comparing biomass to coal, is it more efficient? You can release more CO2 per kilowatt hour in certain cases using biomass, and also you have to then replant things. There's a huge amount of complexity when it comes to this. So I've probably spoken for about 10 minutes now. And I'm just going to give you some key takeaways. And those key takeaways are, procuring green energy can mean different things to different people. So fundamentally, this will have an impact on getting to net zero by your target dates. So make sure you look at your fuel mixes. Figure out which definitions of green energy you want to use. Or rather, I would say maybe you need to be more specific about the types of fuel mix that you're going to procure, especially when it comes to your desired sustainability goals. And I just don't know, is biomass really green? Like, if you ask me, no, but if you ask the EPA, then they'll say yes. Until they change their legislation, and then it'll be a different definition, I'm sure. So yeah, no, thank you very much for having me on. If anyone has any questions around green energy, I probably can't answer any more questions other than the ones I've answered, but thanks.
Thanks, Jordan. It was a really good intro to the session. And it's something that's obviously widely debated. And I think that the point there is that when we're speaking to procurement managers, energy managers, sustainability managers in the NHS, we really need to be thinking about the definition that they have for the green energy, what they're actually procuring, what the fuel mix is, and sort of benchmarking as well. It's like, okay, well, what does good like? What does better look like? How can we actually improve this? So creating those definitions for yourself initially, and then creating improvements on that is what's going to be important in terms of the sustainability reports that the NHS are looking to produce. So I really appreciate that insight there. Any questions for Jordan, please put them in the Q&A section on Zoom, and we can come back to him later on in the session. I'm going to introduce Dr. Azad now. Please, if you can share your screen, give yourself a bit of an introduction, let us know what you'll be talking about today.
Thank you, Georgia. Hi, let me just get this right. Good afternoon, everyone. My name is Azad Kamia. Let me go to the first slide. Very pleased to be here. And I really wanted to talk about a new concept. There's a bit of detail there, but I'll try to keep this to about 10 to 12 minutes. But I wanted to speak about demand-side response. But before that, I've got a nice picture of myself here. I'm the CEO and founder of a company called Pearlstone Energy. And it's lovely to meet you on this webinar. As far as background goes, I joined CGB over 25 years ago from university, just before privatization. And until 5-6 years ago, I used to build power stations, combined cycle gas turbines, mainly Deeside, Killingholme, Little Barford, because I worked for National Power and International Power. I founded Pearlstone about 5 to 6 years ago. I'm very proud to say that we've got 650 investors through different fundraisings, 3 or 4 fundraisings, including the last crowdfunding we had with Crowdcube. So that was a really good platform for us. So let me just start by providing you, just carrying on from what Jordan said, a kind of snapshot of the energy landscape and what the issues and problems are for National Grid, the transmission system operator in the UK. If you look on the left, as far as demand is concerned, when I joined CGB 28 years ago, the capacity margin, the delta, the difference between supply and demand was about 28%. So there was no issues with blackouts because we had 28% more supply than demand. So the capacity margin was very healthy. But during the past few years, demand throughout the day, I was just looking at the capacity that Jordan presented, the delta between the demand yesterday, just under 40 gigawatt, was very close to supply. And I shouldn't give you a lesson on geopolitical tensions and what's happening in the world and energy bills, but it could be, because we speak to Ofgem and based on a regular basis, that we could be in the negative territory where the capacity margin and the capacity squeeze will lead to a kind of negative territory where the supply and demand aren't in balance. And when that happens, there is potential for blackouts. And therefore, National Grid, just as a concept, started these demand-side response initiatives. And why? Because if you speak to BEIS, as far as new generation is concerned, Hinkley Point C, new nuclear capacity, that wouldn't be coming into operation until early 2030s. So we've got 12 years of this kind of capacity squeeze and capacity margin issues. So National Grid said, okay, we need to do something now and today. And rather than building, which is what I've done for the past 20 years, power stations, let us see if we can affect behavioral issues and demand right now in large industrial and commercial facilities. So they kind of created this demand side response. And that is the kind of business we're in. Just to finish on the demand side, the peak demand profile, which has been the same for the past 50, 60 years, typically between 4 and 8 p.m., that landscape is changing as well, because we've got the emergence of EV charging, and it doesn't surprise me if the peak demand profile goes from late afternoon, early evening to midnight because of the EV charging. Now, as far as the supply is concerned, we love renewables. The only problem with renewables, and that's why National Grid actually created the demand side response market, is that renewables is unpredictable, is highly intermittent. Jordan spoke about that. We have a lot of traditional baseload coal and nuclear, the old Magnox reactors being retired because of European directives. And for this reason, we have an issue, as Ofgem said, from this year, if you've got a cold winter, we could be in the negative territory as far as capacity margin, the delta between supply and demand is concerned. So if you look at the opportunity, providing flexibility that enables National Grid to balance the electricity system cost effectively while the energy landscape is changing rapidly is very important. And what the demand side response initiative is that business of all shapes and sizes, large industrial, commercial, retail, hospitals, universities, can now make money because we've got the market for it, to reduce the energy bills, to have some contribution to the journey on net zero 2030, 2050, cut the carbon footprint, and really getting involved in demand side response. I will share all these slides with Georgia and can be shared with you. So I wouldn't go through everything, but I've got more details on slides. So effectively, demand side response plays an important role in ensuring National Grid can keep the lights on a daily basis by balancing supply and demand. Just to let you know, National Grid operates several DSR schemes or demand side schemes. And what effectively happens is that the National Grid DSR scheme incentivizes large industrial and consumers, commercial consumers of energy to turn down non-essential electrical plant, air handling units, chillers, HVAC, pumps, so on and so forth, during times of stress on the grid. Now, from experience, we've got a few customers, such as Honeywell in Bracknell, 3M site. If you look at the peak demand and the peak energy profile in a building, you can comfortably shift or turn down or off 10 to 20% of that capacity during times of distress for National Grid, 4 to 7:30, 8 p.m., without any significant impact on occupants and operations. So we've got the test case and whatever. Just a few quick things. As I said, I've got a few slides, but I wouldn't go through everything. We're a kind of disruptive technology. We create a share of our revenue that we get from National Grid and savings for our customers. Customers really like us because it's not the finance director getting a check at the end of each quarter, but they take their ESG sort of credentials, the environmental, social and governance credentials, which are becoming really important in valuing a company. So basically, I've talked about triple bottom line. So not only we provide economic prosperity and a check at the end of each quarter for our customers, but we also have a kind of social and positive environmental impact, because when you reduce your energy for 10 to 20% of the peak demand, you also provide and lower your carbon footprint. How does it work? Basically, what it is, we've got our hardware and we've got our software. So the hardware is the size of a 14-inch, let's say, PC. I call it the gateway. It's our gateway. It sits behind the building firewall. The hardware is wired to the building management system. Okay. It's also wired to the electricity meter. Our hardware has its internet connection, has its own power supply, and the hardware pulls to our cloud-based platform. That's the other bit, hardware and software. Every minute, every 60 seconds, looking for signals for a potential demand management event. But that is aligned with what National Grid requires. And when the hardware gets a signal from the cloud, then it implements an agreed load shed strategy to say, I take this pump down by 20%. I can't touch that, but I can touch that. A load shed strategy which has already been agreed with the customer, and we've put a line of code on the BMS just to understand what that is. So as I said, I only got 10, 12 minutes, so I can't go through everything. What we do in terms of being aligned to governments for decentralization, ticking the box, decarbonization, democratization, and digitalization. So these are kind of government's aspirations based and on the journey to net zero. Our system, our cloud, our system architecture is 100% cyber secure. Currently, what we do, we enter into National Grid markets, large fast frequency response and store. And we also, if you're familiar, enter into kind of triad season, which is the most distressed for National Grid between November and February, and get your energy bill. And if you're in the southern region, for every megawatt of reduction, you get about 50 to 60,000 pounds, which we will share with you. And the other thing to say, we're a kind of, it's important, there are 10 or 12 companies. If you go on National Grid website, you need to be a recognized and approved National Grid commercial aggregator like Pulsestone to be able to participate in demand side activities. I've given you some examples of the kind of offices we do, what we turn down, extractor fan, air handling unit. In terms of process, very quickly, we don't come to your site. We just get the half-hourly data. That's the kind of your facility's DNA. for the past year. We do some very clever analytics, produce a report to say, thank you for your half-hourly data. We think during times of distress, you can shift or turn down so much capacity. This is how much you get, and this is how many trees you save in terms of carbon footprint. We do the report. We validate our clever analytics by an engineer going with your energy manager and say, yeah, we can turn down this, don't touch that. So there will be a validation of our desktop report, and then we sign the contract, installed, complete 6 to 8 weeks from inception to close, and then we can start savings for your facilities. These are some of our partners: National Grid, Honeywell, 3M, and Cambridge University. I'm a visiting fellow, and we do a lot of research on demand side response, so on and so forth. I think, Georgia, I will stop here. I think I've sort of conveyed the key messages, but I will share the slides with you, which you can pass on to them.
Yeah, that's great. A lot of people have asked actually if the slides will be available.
Absolutely.
And they absolutely will. And there's probably further documentation that you can provide us as well for that write-up. So no, I really appreciate that. And we'll go swiftly on to you, Rupert, because we are running a little bit behind on time.
No problem. I'll present it now. Let's confirm that that's the screen you can see there, Building Intelligence to Improve Our World. Thank you. So good afternoon, and thank you very much for having us. My name is Rue. I am a global solutions consultant for Infogrid. And I'm actually going to turn the coin on its head. Today, we've been talking about the energy supplied and how it is used at sort of quite a high level. What I want to focus on is the management of energy at the single site level. And so I'll come on to that in a second. Critically, I want to take you on a bit of a journey. The world we all live in has very obviously changed. The last few years have been very different. We've had something called a pandemic. We have had a major focus on the environment with COP26, and we've all just lived through in the UK one of the hottest summers on record. I spent hours watering cherry trees I just planted. And going forward, therefore, the demands on us as people, as organizations, and as sustainable and responsible citizens are much higher than they were in the past. But often we're being asked to do this in the sidelines of our day-to-day jobs. So whether that be patients and the NHS being driven obviously by its major stakeholder, us, the citizens, designing better standards, and that might be on the energy usage of a building, how that care is delivered, or the health and well-being within that hospital in terms of better air quality. Will that be higher regulatory demands around compliance and ensuring that we're delivering a better service, but how do we deliver that more efficiently? And then ensuring that obviously net zero is right at the top of the agenda. We all know what the greener NHS plan is in terms of 2040 being the target, but actually 80% by 2032. And so in terms of driving that, this is all against an environment where a hospital is a 24/7 working environment. So it's much more challenging than commercial real estate, for example, to drive down that everyday energy usage because certain assets have to be ready all the time. So just in terms of the challenges we're looking to resolve, the NHS has an incredibly complex estate. The buildings are of hugely varied ages, but as you saw on the last slide, we're going to have 80% of the buildings that we have today will still be here in 2050. So we have to work with the buildings we've got. We can't just suddenly build lots of beautiful new buildings that are perfectly carbon net zero. And actually, it's pretty expensive to do in terms of CO2. The operational cost is typically, in terms of CO2, 80% of a building's running. So what we really need to drive down is not just about the delivery of that green energy, it's about the reduction of that energy in total. There's very little cross-comparison or cross-correlation data across our estates. We don't really have a baseline. At most, maybe you might have it by asset, i.e. by entire building or estate, your energy bill at the end of the year. And hospitals, as I said, are 24/7, so they have different requirements. We can't just turn off floors or wards with the drop of a hat. We've got the greener NHS challenge. We've got to reduce those CO2 emissions, and we've got some quite aggressive targets for a complex estate. And then at the top of that, matters most for the NHS is patient care. So we need to be able to do this whilst retaining strong patient care levels. So when we're being asked to do more, whether that be the nurse who's checking the fridge to make sure the temperature's all right and that the drugs aren't wasted, how can we make her more efficient whilst also ensuring that she delivers a stronger patient care? That rolls into ensuring retention and attraction of talent in an industry that's really under stress, particularly post-Brexit, and ensuring that we have a happy workforce delivering that service. So the NHS Estates workforce plan is really important to that and critical in some of the day-to-day delivery. And in all, therefore, solutions that these guys are operating on the ground from being greener energy need to be simple, need to be intuitive, and we need to be able to stick them wherever we can so that they're nice, easy, and scalable across these very large estates. No longer can we do one glossy HQ and say we've done our job. So imagine being a leader in a world and providing healthier hospital environments. Imagine reducing those operational costs, which are 80% of the CO2 of any building's life. And imagine accurately measuring and hitting those CO2 goals, whilst also delivering high patient care and achieving more efficient maintenance of the building. The challenge we've got, though, is that most buildings are data black holes. So we don't have the baseline data we need to make those decisions. It's all very well saying I'm going to switch from biomass, Jordan noted, to hydro or to wind power. But if at the bottom level, I don't know how much I'm using in the first place and where I'm using that, I need to find that out. Majority of processes are still incredibly manual, whether that be an engineer going around the building, flushing taps to prevent Legionella. Well, that's an engineer wasting thousands of tons of or liters of water a year, tons of CO2 in heating that water just to be flushed when it was probably used 3 hours ago, versus then writing that down on a clipboard or in an Excel spreadsheet. So what can we do to minimize and make those tasks more efficient and thereby in turn be more green? And then scaling that, the change management of rolling out that process across a large estate. That's not easy when you've got over 100,000 employees. I think it's 1 million across the NHS and 100,000 specifically in estates and facilities. So what Infogrid does as a whole, we focus on providing a SaaS solution for the built environment, and we focus on the 3 core areas. Healthy buildings, i.e. us, the occupants using that building. We care about the air quality. Is there a risk of the virus being transferred? Is the CO2 at high or low levels? Therefore, occupancy. Am I providing the right air quality for the right occupancy in that building? And can I up and down that as I need to? Can I wind down buildings or wards that aren't being used for weekends or for certain days? Can I make those buildings more efficient? So the engineer walking around doing that flushing, checking his pumps and his chillers, is there a way I can automate that so that he spends more time focusing on being more green by really nailing down into the points where he can have an impact? Making the cleaning team more efficient so that they're only using certain fluids when they need to, but also they're delivering a high customer service and making sure that patients feel like they're in a clean environment. And then the green thread that runs through all of that, all of these should be more sustainable. So by being more efficient, by being more healthy, how can we make ourselves more sustainable across all of those? And critically, breaking down the silos. Typically, those 3 areas report to a head of sustainability, a head of estates, and maybe a head of in patient care or head of health and safety at a hospital. Actually, they all need the same data, but they just need different outputs from it. So how can we help them all work together to break down those silos and work together to be more efficient and more green? So with Infogrid, what we do is we can simply establish retrofitting sensors across a large estate. They're all very simple to install. And beyond that, it's the algorithms, the correlation of all that data so that we can determine, for example, that a particular ward is of low occupancy, the air quality is great. Actually, you can draw down the HVAC. You don't need it pumping at 100%. We can go down to 80%. We can move to recycle there. And then you can start to see a really big drop down in the energy usage. And we can measure that. I'm conscious of time, so I'm just going to spin through quickly, Georgia. But critically, what we're able to do now is then you can look at each of your buildings in turn, and very quickly you can raise to the surface the ones that need action, those that are not healthy buildings, that are not being energy astute, and can start to think about how you might manage those ones. So prioritizing the ones you need to spend your money on, thereby deliberating whether you need to get rid of those buildings or whether actually you just need to spend some money to make them more efficient, whether that be to replace an HVAC, replace a faulty calorifier, etc. And the impact we can have, even by doing these simple things, is incredibly cost efficient, energy efficient, and time efficient. So, for example, just one corporate office HQ down the road here in London, we installed some solutions there for, frankly, less than the price of the holiday for two. And within 3 weeks, they were able to identify £50,000 worth of energy cost savings. That was 20 tons of CO2. And why was that? They were just bringing on the HVAC an hour too early each day. And for some accident, someone had left it on Saturdays. Really simple, impactful effect. Going back to the day-to-day simple task, like flushing for Legionella, we can remove huge amounts of that from a labor cost perspective, 81 to 91% of time, but also in terms of the impact from the CO2 emissions. If you're not flushing, if you're not heating up that water to be flushed, the impact you have on something that happens every day, almost without any of us noticing, is really low hanging fruit that can drive huge CO2 savings. And then one of the bits, particularly because we don't give them enough time, is our nurses. If they're checking fridges a number of times a day to check the temperature, writing that down somewhere, invariably someone is not on shift, therefore it's not been done properly, therefore there's a compliance risk, therefore we have to waste the drugs because we have to throw them out. If we can monitor that remotely, we give that nurse more time. We also have the ability to monitor that fridge and check it as being energy efficient. And I guarantee you that out of every 100 fridges, there's a couple that definitely aren't being energy efficient because they've been there for 20 years. I was going to close up there, Georgia, but thank you very much. I hope that was interesting, and would love to get some questions.
Super interesting, Rupert, and I really appreciate how granular you've gone there as well. And I think that the narrative of our event has been sort of from Jordan's bigger picture piece right down to the sort of more granular level that you were talking about. So I really appreciate that. Asad, I know that you have to go in 1 minute. Did you want to give any final note, anything that you'd like to comment from the other speakers, or anything that you'd like to leave us with before you go, and we'll just run the Q&A without you?
I'm just conscious of not saying something because I know there's some procurement guys on this call, but just to say, this is the arrangement that we have with our customers, that the hardware and the software and the whole architecture, as far as procurement is concerned, there's no outlay. It's a fully funded solution. Mm-hmm. So we just go and connect everything at our cost, and then share the revenues and savings with our customer. But Georgia, I think there's a lot of detail. This is something we're doing on large buildings now. So I will be happy for you to share my slides, my email address, and my contact details are there. And I look forward to speaking to some of the participants in due course. But can I just say, if there are any specific questions on DSR, I'm happy to stay for another 3-4 minutes. If not, then I go. Okay, I don't see anything on the chat, but of course you can share my slides and I can talk to people later.
Okay, no, there wasn't anything specifically about
okay.
DSR stuff, but I'll let you know if any do come through as well, and you can go back to people in your own time.
Thank you,
okay.
Georgia.
Thanks so much for joining us.
Okay, thanks guys. Cheers, thank you.
Jordan, I wanted to jump in right now. I know that you've had a lot of conversation here in the chat, a lot of stuff about carbon capture, people agreeing with your whole thing around biomass and that kind of stuff as well. And I know that you are working, as you said at the beginning of your presentation, with the, the smart buildings piece with NHS. I wonder, do you, when we're talking about that energy mix piece, are people who are procuring energy, are they made aware of that stuff? Do you feel like
well, there has to be. I mean, from a suppliers are regulated to be able to disclose the fuel mix as part of regulations, especially in kind of the commercial industrial procurement side of things. I think when it comes down to, like, you know, we're a technology business. We don't really focus massively on things like the fuel mixes and procurement side of things. And it kind of comes back to kind of what Rue was saying, really, is like what we tend to do is find ways of servicing data or optimizing assets, right? And that usually comes down from a technology or a business process perspective. What's interesting is that the fuel mixes and how they, at the end of the day, your annual reports to the sustainability credentials or what you're trying to achieve from a KPI perspective, like fundamentally how much energy you use, you know, and with the fuel mix will contribute to your, to whatever you're doing with your carbon output. So I think, you know, the fuel mix is really important. A lot of energy procurement folk will be very much hot on that, I would imagine, and especially now the net zero piece is so high on the agenda over the last 18 to 24 months. What is just kind of frustrating from my perspective on a personal level is genuinely that there are certain types of fuel that are considered not green, or certain types of fuel that are considered green that really maybe aren't. And I also think that legislation here in the UK is a bit difficult, because if you, as you saw from some of those graphs, you know, the lowest carbon output is wind, and there is actually quite a lot of, I suppose, and solar, and there's quite a lot of government red tape going that way to kind of reduce the ability to do things like onshore or offshore wind, and similarly with solar on agricultural land as well, which I understand there are some benefits and there are pros and cons. So it's unfortunate that, as you saw, and that's my final point on this, is that when you look at the fuel mix overnight, you're using 50% gas. Like, so it doesn't matter how much you're buying, right? The physical electrons that are running through your plugs in any building will be produced by the UK's grid, and whatever that fuel mix is at the time, you are effectively buying sources of energy from a procurement perspective for your sustainability goals. But that doesn't necessarily mean the actual energy you are using at that point in time is completely carbon neutral. It's just not, right? You saw that at 6 o'clock last night. So yeah. It's something that I like to talk about, but with the NHS Smarter Buildings program, that's actually the wider estate and how we kind of develop the ecosystem to allow connectivity of IoT assets across the whole NHS estate, essentially, like in a standardized way, basically.
Well, it sounds like you're creating the awareness, even if there isn't any.
Yeah. I'll go into those technical calls and be like, think about the fuel mix, even though we're talking about air quality sensors or whatever it may be, right?
Yeah. Rupert, I think that's something that we've talked about quite a lot in our reports and on our events in the past, is that sort of silos of data, and particularly between trusts. Everything sort of gets siloed. Oh, we do things this way, but actually the whole reason for sustainability partnerships is to allow for a platform for sharing of innovation and insight into what other people are doing. And what we've heard in the past as well is that one of the biggest barriers is a behaviour change on the front line. From a grassroots level, it's incentivizing that actual behaviour change. And I wondered if you guys do anything to produce reports that are a little bit more user-friendly for the people who are actually going to have to be implementing that change. You talk about the nurses, the cleaners, the engineers. Is there anything that you guys that make it a little bit more tantalizing than just a load of graphs like, hey, you need to do this, you need to turn off your HVAC at 6 p.m, what that kind of thing?
That's a really great question. So what we're definitely seeing is a demand for, I think, probably 3 key things. Number one is what you said is around actually that recommendation piece. So making the adjustment easy. So if that recommendation is sat there for me in an accessible format, and you can choose that format, whether it's a monthly report, a weekly report, a text, whatever it works for that person. I think that flexibility is important because people work in different ways. To have that recommendation, so say, have you thought about that actually your busiest time is this, you should probably increase the HVAC at this time, versus maybe at this time it's really quiet, maybe we can do something about that. And then I think the key bit around incentivization, I think is a really good point, is what we're seeing as a request for leaderboards and for public dashboards.
Right.
So number one, so literally whether it's ward A versus ward B, like who's being more energy aware. Now obviously they're going to have different assets, so you can sort of balance it out so that it's you can see which are badly performing assets, what are they doing about that, how have they changed that over time, so you get that trends, that sort of competitive feel. But also dashboards as you work into the hospital, and what I mean is big screens on the wall, increasingly in demand for that, so that the hospitals can show that they are being publicly conscious of that energy consumption and creating a healthy environment. One of the bits I thought was really interesting was the NHS Estates and Workforce Plan, where clearly with recent changes in terms of the challenges around the workforce, particularly post-Brexit, and retaining that talent. And so one of the simple things we find is that because people are now empowered to have that change, rather than being told what to do, they now have the power in their ability to affect that change. We're actually seeing much more satisfied workforces, because sometimes we're able to give you a feedback opportunity and it's immediate feedback. But also if there's a problem, it's an immediate resolution to a problem, rather than someone whinging about it in an email to you 3 days later after they've left the event. Actually, did you know that such and such is broken? Hit a button, it's anonymous, someone can do something about it straight away, it goes to the right person. Vice versa, that ability to have feedback that is positive, that you can then go, great, I did a good job today, or I was actually able to think about my job and do it in a way that made more efficient sense for me and delivered a better outcome. So putting the power into people's hands, rather than saying at 6 o'clock you must do this, at 8 o'clock you must do that, at 10 o'clock you must do that.
And yeah, it's a little bit of friendly competition on dashboards and stuff is never a bad thing, is it? To say, we're making these changes. There were some more questions. I think, Jordan, you're going back and firing back answers to people yourself in the chat.
I'm a keyboard warrior right now.
Yeah. No, that's fine. Did you guys have anything else that you wanted to add? Because I've just got a couple of bits that I need to go over before we finish.
No, I just wanted to say that if anyone wants to get in touch with us, we're over at harksys.com, or you can email me at jordan@harksys.com. And that's the best place to get me if you want to continue the discussions about carbon capture or biomass. I'm down.
Not like you have a day job or anything.
Yeah, I also have my day job too. That's correct.
And Rupert, was there any final thoughts that you wanted to add? I know that it's a huge topic to try and fit into an hour, but I really appreciate everyone's how you've tried to get in as much as possible.
Yeah, no, similarly, obviously, if people want to know more, head over to the website, infogrid.io. There's a load of case studies on there, many of which are NHS relevant. But critically, I think, don't be surprised by how easy it is. It's scary, it's technology. There's all sorts of weird infosecond stuff. We can get around most of that by making sure that it's really simple and affordable and scalable and critically sustainable. So it's a scary area. There's loads of regulation, but actually we can work with you to help walk through that challenge.
Okay, wonderful. So I've reserved myself the last 5 minutes because I need to share with everyone that sorry?
Big question from Reza there to finish with on the chat.
Oh, I didn't see it. I've started sharing. I'll come back in a second. But I do need to share that the Sustainability Partnerships awards are back. Our awards, they're all about showcasing organisations and NHS trusts who are striving to implement real sustainable change for our future of our greener NHS. They're there to benchmark amazing achievements made by and recognise leaders in the field, and the awards have brought last year's awards brought some light to some of the journeys some of the trusts have made on the agenda, and also some of the businesses who are dedicated to developing new products and services to help the NHS along. There are awards for the NHS trusts themselves, and then there are awards for businesses who supply into the NHS. So here are some of the categories. We've got food reuse, so all about circular economy, clinical, procurement, public engagement and staff engagement. So that's all about how your trust has been engaging with your staff, like Rupert was talking about, bringing about systematic change and behavioural change, and then public engagement and how you're dealing with your local area and creating more of a holistic sustainable change there as well. So all of those are absolutely free to enter. For businesses, please submit any of your entries. We've got Supplier of the Year, we've got Innovation, Infrastructure, Waste, Transport and Carbon. So please, all you need to do is visit our website. Every one of them is absolutely free to enter. All you need to do is visit our site and go to the awards page. You need to download your submission form then, and then just send it over to us in an email. You can send over whatever videos, photos, any extra stuff that you thought would be great to get you on the winner for that. The deadline is the 31st of October, so Halloween. You've got until midnight on 31st to submit your award entry, and then we'll be announcing all of the winners in the webinar, which is not on the 6th of November anymore. It's actually going to be on the 10th or the 6th of December. So I'll just stop that sharing there. And I think, yeah, one of my team has actually already put the link there into the chat, where you can go and register for the awards. And finally, we also have our next event coming up, which is with our partner. And I'm just going to get the information up for that. It's with our partner. We do have the link for that as well. Sorry, I'm just trying to get that. Oh, it's not live yet. Sorry. So our next event is going to be on the 23rd of November. That's with our partner Connected Curb. It's all about the future is electric, transforming transport in the NHS. We're going to be exploring the debate around charging stations in the NHS, electrifying the fleet, all that kind of really interesting EV stuff. And that's going to be an hour long with Connected Curb themselves, and they're going to go really, really deep into insight around what they've learned and what they can help out with in terms of electrifying the NHS. So with 1 minute left, I need to say thank you very much to everyone who came to our event today. As usual, the entire thing will be written up on the NHS Sustainability Partnerships website. In a blog, we'll share all of the contact details, all of the slides, and everyone who signed up will receive a link to that write-up as well as the video so that you can watch that back as well. Thank you to Nathan, my co-founder, who's always here supporting sustainability partnerships, to Rupert, to Azad, who had to leave a little bit early, and to Jordan. Thanks so much for sharing your time and your insight today. I think there has been a lot of really great chats. I wish that we had a little bit more time to talk more about that. There's, yes, some really good questions there as well that we're going to have to have missed. But Greg, the webinar is in the chat there just above your comment. But thanks so much, David Nurse, always joining us. I really appreciate that. And for everyone on my team who's helped to put this together and all of the events going forward. So really looking forward to seeing you again at our next event. Please go ahead and submit your award entry. There's absolutely nothing to lose. It's really quick and it's completely free. So we're looking forward to seeing all of those entries come through. And we'll speak to you again on the next event. Thanks, everyone.
Thanks, Georgia. Well done.